Okay, so we're trusting AI with more and more stuff every single day. But what happens if that trust can be completely shattered? What if an AI can be tricked by attacks that are so subtle they're literally invisible to us? This right here, this quote from the researchers at XCube Labs, it just nails the core of the problem. We're not talking about huge, obvious hacks. We're talking about tiny, almost imperceptible tweaks that can cause an AI to completely misunderstand reality. So let's paint a picture. You've got this top-of-the-line AI, right? It's been trained on millions of images, and you show it a crystal clear picture of a panda. It nails it, identifies it with super high confidence. Seems simple enough. But then you add this tiny, and I mean tiny, practically invisible layer of what they call digital noise to that picture, and bam, the exact same AI suddenly becomes 99% certain it's looking at a gibbon. To you and me, the panda is still perfectly clear, but the machine, it's been totally fooled. Now, this isn't just some random computer glitch. No, this is a deliberate, carefully crafted attack, and it shines a huge spotlight on a fundamental weakness in how these AIs actually perceive the world. So, how is that even possible? All right, let's get into it. We need to explore what's called the AI's blind spot. This is all about the massive difference between how an AI sees the world and how, we do. Okay, so the official term for this is an adversarial attack. The best way to think about it is like a super sophisticated optical illusion, but one that's designed specifically for a machine, not for us. These distortions are engineered to exploit the AI's logic and just force it to make a mistake. And if we go back to that famous panda case, that noise they added, it wasn't just random static. It was specifically calculated to game the system. See, the AI doesn't see a panda. It sees a collection of pixels and patterns. And to the AI, that noise was a giant blinking sign that screamed gibbon, even though to our eyes, it's nothing. And look, this is where it gets really serious, because this isn't just some fun experiment for researchers in a lab. These attacks have major and sometimes pretty scary consequences out in the real world. I mean, think about it. We're putting AI in charge of some incredibly high-stakes stuff, from self-driving cars on our streets to systems that analyze medical scans. A successful deception in one of those fields? Well, the potential impact is a massive concern for safety and security experts everywhere. All right, check this out. Researchers from McAfee did this real-world test on a Tesla. All they used were a few small pieces of black tape to slightly alter a speed limit sign. Super simple, something a person would barely even register. So what happened? The car's AI looks at that modified 35 mile per hour sign and completely misreads it. It sees 85 miles per hour. A human driver would just see some tape and ignore it, but for the AI, that was a command to accelerate. That's a potentially catastrophic error. And it's not just about physical things like signs. This vulnerability exists in the digital world, too. There's this now famous case where researchers tweaked a photo of a cat just enough to fool Google's Cloud Vision API into thinking it was guacamole. Yeah, guacamole. Okay, so that's the what. But how? How exactly do attackers pull this off? Let's break down the anatomy of one of these attacks. So attacks basically fall into two big buckets, and it all depends on what the attacker knows. You've got white box attacks, where the attacker has the full blueprints of the AI. Then there's black box attacks. That's more like working from the outside, just poking and prodding, feeding it stuff and seeing what comes out until they find a crack. The folks at NIST, that's the National Institute of Standards and Technology, they break these threats down into four main types. There's evasion, which is exactly what we saw with the Tesla sign. But attackers can also do things like poisoning the data the AI learns from, trick it into leaking private info, or even abusing its sources by feeding it bad information. So, with all these threats, you might be thinking, we're in big trouble. But researchers and engineers are fighting back. They're basically trying to build a digital immune system to make AI way more resilient. The defense isn't just one thing. It's a whole strategy. Adversarial training, for example, is kind of like giving the AI a vaccine. You show it both clean data and known attacks, so it learns to spot them. Other methods, like ensemble learning, basically team up multiple AIs, making it way harder for one attack to fool the whole group. And a huge part of this defense is, believe it or not, trying to break your own system. It's a process called red teaming. You get a team of ethical hackers to act like the bad guys, to find all the weaknesses before the real bad guys do.
And this here is a perfect example of modern red teaming. What you're seeing is an attempt to trick a large language model, think something like ChatGPT, into completely ignoring its safety rules just by using a cleverly worded prompt. It's a constant cat and mouse game.
Zooming out to the big picture, you have frameworks like this one from NIST that give companies a real game plan. It's all about creating this continuous cycle. You govern, you map out the risks, you measure them, and you manage them. The key takeaway is that AI safety isn't a one-and-done thing. It's a constant process.
But here's the kicker. Even with all these smart defense strategies, this is an ongoing battle. It's a never-ending arms race. As the AI gets smarter, the attacks get more sophisticated.
And this isn't some far-off future problem. It's growing, and it's growing fast. The tech analysts at Gartner are predicting that by 2025, nearly a third of all cyber attacks on AI systems will be these kinds of adversarial attacks. That's huge, and it's going to affect every industry using AI. And hey, don't just take my word for it. The experts at NIST are pretty blunt about this. They basically warn that there are no perfect, foolproof solutions right now. So if anyone comes to you saying they can make an AI system 100% secure, well, they're selling you snake oil. Which really brings us to the big, critical question we all have to think about. As we keep weaving AI deeper and deeper into the fabric of our world, into our cars, our medicine, everything, how do we build trust? How can we trust a system that we know fundamentally can be deceived?